Good morning. Good morning to culture. Good morning to anthropology. Good morning to all. Good morning to you that are here, and welcome to the Curaçao Cultural Landscape Project Symposium, CCLP. It is an honor to be here and moderate for you in this platform, Digital World, Digital New Ways, Digital Age, and my name is Elton Villarreal. And today, I will walk you through a series of very interesting talks and information about the CCLP project, the Curaçao Cultural Landscape. If you're talking about Curaçao Cultural Landscape, what is Curaçao Cultural Landscape? What is CCLP actually? Well, today, the archaeologists, I will mention them and all our partners, they will go with you through presenting preliminary findings that they had here on research that they did in Curaçao. Of course, you may have questions. You can submit those through either Facebook or our YouTube channel, and we will have all of these written down and post to the presenters. I'm looking into it and I'm like, how did we achieve this? How did we reach here? Well, we couldn't have done this without our sponsors and collaborators. And for that, I'm going to mention them so I don't forget anyone. So, CCLP is a collaboration of many years, not only 1 year, but many more years to come, between the National Archaeological and Anthropological Memory Management Foundation, very long name for NAM. It's between the Social Sciences and Humanities Research Council, the Simon Fraser University, the National Geographic, the QLC Incorporated Interest Registries, the Max Planck Institute, and the University of Queensland. Now, of course, this research couldn't be done without people, because the machines don't work themselves and they don't do the research. So I want to thank all the participating archaeologists and the volunteers. Participating archaeologists in this project: Dr. Anders Claudia Kraan, Dr. Christina Giovas, Mr. Michiel Kapers, Dr. Kesley Low, Ms. Yoshi Meizumi, Ms. Christine Konian, Ms. Amy Victorina. Yoshi Meizumi, Christine Konian, Amy Victorina will not be present today. They will not present in their findings today. However, the others will, and we will have some of them being virtually just a pre-recorded presentation, and the others will be live. A special thanks to the students of Simon Fraser University, local volunteers, Nifa Ansano and Creative Inspirations, Base Creatives, Cura Livestream, Rafael Maduro, which is the intern of the National Archaeological Anthropological Memory Management Foundation, the NAM. So I've talked a lot. I want you to get into the gist of it, and I want you to know why I'm so inspired for today. Well, the first day I heard about CCLP, I was like, what is CCLP? And then I got a presentation. And what I heard of that presentation was that I didn't even know all the things that could be found on our island. Such a small island with such a rich culture. So today, we will be shaping in a new way, moving forward, seeing as the end of the year, starting anew. Is it the end of the year or is it a new beginning? Also for Curaçao Cultural Landscape Project, CCLP. Without further ado, I want to pass the floor to the director of NAM, which is Mr. Dimitri Klose.
Good morning. As the director of the National Archaeology, Anthropology, Memory Management of Curaçao, I'm proud to host the first online symposium and the preliminary findings of the Curaçao Cultural Landscape project. We hope that the results can contribute to contemporary issues such as climate change, but also on other burning questions that we have about our past. For instance, the introduction of flora and fauna on the island, and or about our prior inhabitants of the islands. I think that cultural studies can contribute much more to present issues than just about the past. A huge mistake often is made that studies such as anthropology and archaeology only contribute to the past and our heritage. We study the past, but most of the time the focus is not on the present and especially not on the future. If we only study the past, we will only live in the past, and we're surpassed that. So most of the time we can use the new science to understand much more where we're going and where we're heading at the moment. We learned to use archives as our primary sources. While these were drawn up by colonial identities, points of views, mainly on economic, military, and financial data, that are their main interest. While communal activities, social relationships, daily practices of people were barely recorded. So if there are documents available, most likely they're about law, on public order, or some kind of other jurisdiction that they had. So if we want to find out more, we got to go to the oral traditions and other kind of forms of transmission that we can learn more about the past. The same is for excavations. Most of the time we learn how to excavate in moderate temperatures, in loose soil or in clay, while when we're doing research on the islands, we do much more research on heavy, hard rock in the hot sun, or even what happened during the excavations of the Cultural Landscape project and what we're having now in Curaçao are very heavy thunders and rainfalls. So it's a much different approach of how we do most of the things on the island that's different from what we learned and what we do every day. But collecting data is our main interest, and how we collect it. So if we cannot get it from the archives, or we cannot get it from just what we had in the ground, we need to do deeper research. And that's the great part about this project that we did, the Cultural Landscape project. We tried to get as much people in, as much disciplines, different researches, different point of views, and still doing a research where everybody is equal, where everybody does what they do best for the main interest that's just for the island itself in one way or another. And hopefully with these findings that we're going to introduce to you today, we can do much more in where we want to go with not just the research, but with data collections, make it accessible for people, getting new insights, and where we want to go with everything. So I'm very honored, as I said, I'm very privileged that we could do this project for the first time on a very international level with a lot of people, with a lot of institutions. I want to thank everybody that did their part on this one, all the institutions, the sponsors, And I hope that it will be very interesting in whatever findings you will get today. So please let us know what we are, and hopefully you'll enjoy the day. Thank you.
So, thank you to the director of the NAM, Mr. Dimitri Klose. And I stated already, is this the ending or is it a new beginning? So, as Dimitri mentioned, from the past, moving from the past in one way of collecting data to the new way of collecting data, and then presenting this. So collection of data is very important. So to move over to this, we are going over now to the first presenter of the day, which will be Dr. Anders Claudia Kraan. Dr. Anders Claudia Kraan is one of the archaeologists and is the deputy director of the NAM. She's a specialist in Curaçao archaeology and archaeological heritage management. So, without further ado, with you, Dr. Anders Claudia Kraan.
Thank you, Elton, for your introduction. My first presentation this morning will be about the Curaçao Cultural Landscape project itself, but also I will give some context to the other presentations. To do that, I will talk a bit about how this project came about, what it entails, and also tell a little bit about Curaçao, its climate, and its past inhabitants. This project came about started in 2018 when Michiel Kappers and Christina contacted me, which resulted in a visit by Christina in May 2019. We planned a field school at first for 2020 and then for 2021, but unfortunately 2 lockdowns came in between, but that also gave us the opportunity to get more funding for our project. The financing of this project is provided by all our directors' organizations, the National Geographic Society, Community Engagement Initiative, and the Social Science and Humanities Research Council of Canada. And also, of course, the field school students. The context of the project, and for people that are not familiar with the island, I'm presenting you some facts. This is a map of the area where Curaçao is. Curaçao is an island off the coast of Venezuela, and it's an autonomous country within the Kingdom of the Netherlands. It's also appointed by UNESCO as a small island developing state. Its climate is semi-arid, and from February until March, those are the dry months, and October until January are usually a bit wetter. In historical sources, we also see some extreme droughts where people and cattle perish, and there's a lot of food and water scarcity, especially in the historical colonial period. The peopling of Curaçao started about 5,500 years ago, and that's when we find the first evidence for it at the Roy Rincon site. And around 2500 BC, we also find in the first possible indications for horticulture and burials. Around 800, the Caquetillo arrived from the mainland of Venezuela, and those were also the people that met the Europeans, the Spanish, that were coming to the island in 1499. Yeah, this is a timeline of the colonial period. So the Spanish came in 1499, as I said, and they stayed on the island until about 1634, when the Dutch West India Company took the island over from the Spanish, and it continued to be a Dutch colony until 1954. In 1954, the Netherlands Antilles were created as a country within the kingdom, and that took until 2010, when Curaçao and Sint Maarten became autonomous countries within the kingdom. Our goal for the Curaçao Cultural Landscape project is to create a deep time reconstruction of the natural environment and biodiversity, and it's a multi-disciplinary approach. And also, which is very important for us as a local organization, is that it's rooted in local heritage management, government and community. This is a large focus of our project. For our fieldwork, we chose first, the activities within our project. We did some archival and literature research, which I will go into in my second presentation. We organized fieldwork, but also public participation opportunities. For the fieldwork, we chose 2 bays on the island, one in the more western part, and that's Sainte Marie Bay, and one in the eastern part, and it's the Yantil Bay area. We chose those locations based on accessibility, ownership, and developmental pressure, and also the presence or non-presence of archaeological sites dating from the archaic early period until pretty recently, until 1950. To go to the base itself, this is the Yantil Bay area. You can see that's pretty green in the close to the bay. That's because this is a conservation area. You can also see that the area around it is very urban, and there's a lot of pressure from people walking and biking and hiking in this area. To go back to the Yantil just for one more minute, that you can see the salt pans. There are salt storage is in the south. There's a lime kiln, and there are several indigenous sites in the area. The Sainte-Marie Bay area is more of a rural context. As you can see, it's also a conservation area and a Ramsar site. The east part is part of the becoming a national park, the Rif Sainte-Marie Hermanus National Park, and the whole area is actually used for hiking and biking and fishing. If we look at the heritage, there are some indigenous sites and village of the enslaved, some indigo cisterns, and remains of mining activity. But all those activities in the past I will go into detail in my next presentation. For the field work, for the field season this year, that was planned in July, and we did some test pits at archaic sites near both bays, and we started looking and measuring, describing a part of the salt pans of the Yantil Bay. We also made some test pits in the enslaved village of Sainte-Marie and the area of Dendunki Park in Zuurzak in the north of the Yantil area. Well, the public outreach that we have within our project was that people could participate in fieldwork and fine processing on our volunteer Sundays. We held an open house, which was visited by about 200 people. Also, we had a citizen science zooarchaeology course presented by Christina. This symposium, of course, we had a lot of social media presence, and we're also planning, or we have planned, a stakeholder meeting on next Friday. Well, the presentations today are very preliminary results because the analysis is still ongoing. So, but we would like to present just our first findings to let people know what we've been doing. We're also going to prepare for the next field season, which is planned for 2024, and hopefully we will be able to continue after that a few years in a row. I would like to say a thank you to the directors and their organizations, the participants of the symposium, the landowners, the local volunteers and participants during our fieldwork, and the promotion and symposium organization, especially Niva Ansano, Rafael Maduro, Base Creatives, and Curaçao. Thank you.
So, thank you very much, Dr. Anders Claudia Kraan. Now, she's coming back in just a few seconds, but now, not to introduce the Curaçao Cultural Landscape Project, but to speak about the historical evidence for environmental and biodiversity change in the Sainte Marie and the Antille areas of Curaçao. So we'll get a little bit more of insights of what research has been done, what the preliminary findings are, and you can ask questions about where they are going for next week, seeing that there have been preparations for the ongoing research. Without further ado, again, Dr. Anders Claudia Kraan.
In my second presentation, I will address the historical evidence for environmental and biodiversity change in the Sainte Marie Bay area and the Antille Bay areas in Curaçao, based on a desk-based assessment that I wrote on those research areas for the CCLP. The archival research for this desk-based assessment was done by André Rancuret. Well, the aim of the desk-based assessment was to support the different fields of interest of CCLP, which were the pollen study by Yoshi Maizumi and the use of fire, the zooarchaeological research, the indications for site structures and especially plantation structures in the areas, for dating sites, but also historical context for other archaeological finds and features. My second presentation is organized as follows. I will start with introducing the resources that I've been using. Then I'll create the general picture of the island based on historical sources, especially the early period, and then I'll focus on the two plantations around the bay, the plantations around the bay in the 17th until the 20th century. And I will close with some concluding remarks. Well, as resources, I used historical sources and archival documents from the National Archives that were collected by André Rancuret, and they were especially sales inventories of plantations. And also we looked at historical maps. As I said in my first presentation, the historical Cactillo people were the people that met the Spaniards when they arrived here in the Caribbean or on the island. And it is thought that the Cactillo introduced the indigenous deer on Curaçao, but also corn, cassava, and perhaps tobacco. In a letter of Jan van Wabbeck in 1636, an indigenous informant tells him that the indigenous people of Curaçao had the following food to their disposal, and that was cassava, corn, a lot of fish, iguana, sea turtle, lobster, sweet potatoes, bananas, pumpkins, melon, and other Indische vruchten, or local fruits. I must say that bananas, of course, and melon were introduced later, and probably during the Spanish colonial period already. Also, a thing to mention is that they say that the indigenous people went fishing near Klein Curaçao, a small island to the eastern side of Curaçao, and that they were hunting for seals and sea turtles that they traded with the people on the Venezuelan mainland. During the Spanish colonial period, the ABC Islands were called the Islas Inútiles, but there were still a few Spaniards on the island, or at least on Curaçao, with a larger group of indigenous people that were taking care of the cattle on the island, because those were introduced by the Spaniards for their meat and hides to sell. Also, they were growing plantains, limes, oranges, pomegranates, and sugarcane. Well, during the West India Company, starting from 1634, the indigenous people and also the enslaved people on the island had their own small gardens, and in historical sources you can see that employees of the Dutch West India Company were forbidden to steal crops from those gardens. So that was actually an issue, probably due to that the European people or the Dutch people didn't know how to grow their stuff. That's also something that we see in a letter from Johan van Walbeek, and that they had difficulties planting wheat, rye, and tobacco seeds from Trinidad. And that Johan van Walbeek sends his planter to the indigenous people on the island to ask how to grow crops. And the indigenous crops that are mentioned at that time are corn, cassava, sweet potato, beans, plantain, melons, pumpkins, and watermelons. And watermelons, of course, and plantains and melons were introduced by the Spaniards already earlier. But the indigenous people included those crops in their agricultural activities. Another thing that's mentioned by Van Walbeek is that they succeeded in growing some radish and cotton and lime, and they went to Bonaire to collect or hunt seals and salt, to collect salt on Bonaire. And of course, a lot of woods or trees have been cut down in this period and exported, which influenced the environment greatly. If we look at the Simarible plantations, there are actually two larger plantations in the 19th century, the early 20th century in 1911. This is the Werbata map with the Oud Sint Marie plantation on the eastern side and the Rif Sint Marie plantation on the western side of the bay. You can see that the mouth of the bay is very small, and that's been in earlier eras as well, or at least in the colonial period, because on other maps you see the same. And there's also mention that it can only be used for small vessels, so that makes this this bay from the beginning a lot more salty than other bays that are more open to sea. The Antille Bay and the plantations are visible on this slide. In the western part you see Coralspecht. Above that one is a smaller one that's called La Badera. In the north there is Zuurzak. And in the western part there is the Antille plantation. This bay is not indicated on the earliest maps, and it's probably due to that the Spaniards, but also the Dutch, were looking for areas where they can, or bays where they can move in their larger vessels. So this was a salt lake, or a natural salt lake or salt pen that probably has been used very early on. If we look at plantation structures that we find, is that there is a general idea or development that you can say that the plantation has certain features, and that's that there was usually a plantation house, enslaved huts, storage or warehouses. There were walls and cacti fences, corrals for cattle. There were also made some dams to create water wells, or at least locations where the water would stay for a longer period. They made stone wells. There were greenhouses. That's the only mention of greenhouses was actually in Saint-Marie. Other plantations, I'm not aware of those, and I have no clue actually, or no indication what they have looked like. There were paths and roads, of course, indigo structures, and salt pans. And I'm going to go through some slides with some how those features, what those features look like. This is the plantation house of plantation Zuurzak. Oh, sorry. This is, yeah. This is a shape, at least a shape of an enslaved hut. This is not originally built, or at least this is, at first, of course, they were made from wattle and daub, but this one is made from coral stones and plaster. So this is probably a later development, but this is just an example of it. Those are cacti fences. This is an example from Bonaire, but those are also visible on Curaçao still in some places. This is a slide from the salt pans from the air, and this is a detail of the walls that we still have in the area. This is those are the salt pans from the Antil Bay. You can see those walls are still there, and they are in need of preservation. Another thing that is especially for the Zuurzak plantation is that there was a decorative garden created in the 19th century, and this is a bridge that was part of this garden. Other activities that influenced the environment were mining. There were lime kilns and stone crushers, and they were used to produce construction material. This is the stone crusher from the Saint-Marie plantation before it was moved to the Coral Estate resort. Well, if we look at animals and plants here, the mammals that were introduced in the colonial period, there were goats, sheep, and the Dutch colonial period, cows, horses, mules, donkeys, pigs, and oxen. And also a lot of birds were mentioned in the inventories of the plantations, like turkeys, chicken, ducks, pigeons, geese, peacocks at sometimes. If we look at plants and trees and crops, those are less mentioned in the inventories, but they do mention sorghum and corn, coconuts, linseed, peanuts, beans, blessed thistle, and mangrove wood. And another thing which has influenced the environment or the landscape a lot is the free roaming goats. There is still mention in the 1980s that there are free roaming goats, and actually in my street there are sometimes goats walking about. And the last thing that I would like to mention is that in the early 20th century they created dams, because in the 19th century, because of all the deforestation that took place of all the trees that were exported and used and cut down, They created dams to make sure that the water, if there was any rainwater, that it would stay on the island and could be used for watering plants and crops, but also their animals. Well, to conclude is that from the early on, there was introduction of several species and also deforestation. There are a lot of remnants of plantation structures that, by being created there, influenced the landscape of the island. There's also the introduction of large mammals and birds, especially in the Dutch colonial period. We also have dams, decorative gardens, and free-roaming goats, which had a large influence. And if we compare the information of those two bay areas, and the plantation is more or less similar to the situation on other plantations in Curaçao. Thank you for your attention.
Yoshi, you are one of the researchers working on the project Curaçao Cultural Landscape. What's your specialty?
I am conducting the paleoecology component of the project, and this is going to be reconstructing the past ecosystems. We're really interested in how humans interact with the environment from the time they arrived here on the island. And this is talking about the indigenous peoples and then kind of how those relationships with the environment changed from the past and then through the different phases of human occupation. So as the colonial people came in and then more towards the historic period and modern period, how human interactions with the environment changed.
Okay. When you say that, how do I assume you're going to get the information for your research?
Right, so my main research specialty is to look at the sediments that accumulate in the bottoms of the bays and lagoons in the area. So if you imagine there is a community of people living around the lake or water body, kind of everything that's going on around the landscape winds up into the surface of the lake and then kind of settles down through the bottom and starts to accumulate through the sediment. So if we have flowering plants, for example, on the landscape, the pollen that's produced by those plants, little grains of pollen wind up in the lake, down in the sediments. If a fire happens, the charcoal that's produced during that fire also washes into the lake. Then fast forward thousands of years, if we then go and collect those sediments, we have layers throughout that sediment core that'll show you changes in things like fire activity and vegetation that occurred during this period of human occupation.
Okay, but how do you, on the islands, the archaeologists go and they make a test pit and then they dig with shovels and stuff like that. How do you collect your samples?
So we've got a raft, kind of a raft system with a platform, and we'll paddle that out to the middle of the lagoon and anchor it out, and then we have some special coin equipment that's used specifically to collect those sediments. Okay. It works kind of like if you've ever had like a milkshake and a straw in the milkshake and you put your fingertip on it and you draw that straw and then the milkshake stays in the straw. It's a really similar system that we have for pouring. Basically, it has kind of a piston or a plunger at the top of it, and then as you collect the core, it creates a suction, and so you're able to pull those sediments out from the bottom of the lake.
Okay, so simply said, is, if I can put it like that, coring is like collecting dirt in a straw, in a tube.
Maybe sediment in a tube.
Sediment in a tube, yes. Not dirt, but
it's more important than dirt.
Okay, yes, I understand. Sediment in a tube.
Exactly.
Okay.
Exactly. And then, you know, in theory, the stuff at the top should be younger, the stuff at the bottom of the core should be older, right? So then we can radiocarbon date that, figure out how old the sediments are, and then use that to reconstruct changes through time.
Okay, you are from the Max Planck University in Germany, but you came now to Curaçao from all the world. Why Curaçao?
So particularly, I'm interested in how humans interact with island ecosystems. So islands themselves provide this really amazing kind of natural laboratory to look at kind of a small confined area where you can look really closely at vegetation and changes on the landscape, introduction of different species, introduction of humans, and understand that those dynamics on kind of a micro scale. And so I actually had a project I started in Jamaica a few years ago looking at very similar questions, but Jamaica, compared to the other Caribbean islands, is one of the very last islands to be colonized by humans, whereas Curaçao is one of the very early ones. So it's a way that we can start to compare if you have humans on this island, let's say thousands of years longer than you do on another island, right, nearby, relatively nearby. What then are the changes or the kind of different histories of land use in these islands? So I came to Curaçao originally with my former University of Amsterdam to the research station here at Kamabi, and started chatting with the director at Christophe there about the vegetation, unique vegetation in Christophe Park, and that's kind of how we started this conversation about potentially looking at vegetation change on a longer term scale, and then met some of the researchers here at NAM, Claudia specifically, and we started talking about potentially, teaming up this paleo-ecology perspective with the archaeological perspective, and kind of grew into this bigger landscape project.
Nice. And what are you hoping to gain? You said you compared right now Jamaica with Curaçao. What are you hoping to gain out of the project on a bigger scale?
So what this type of research provides is that it gives an idea of human land use practices for thousands and thousands of years. And so oftentimes the land use practices that are going on, not just in the islands, but kind of ecosystems in general, are not sustainable. Right? A lot of this stuff is very extractive and damaging to the biodiversity and the vegetation and the soil stability and all sorts of things. Well, if we have histories and examples of humans living on the landscape in a much more, quote-unquote, sustainable way, it gives a kind of an example of what types of land use practices they were doing. Were they practicing things like agroforestry? And this is going to be, maintaining the natural forest composition for plants that are useful, medicinal, edible, that kind of thing. Mixed cropping, not just cropping single types of plants, but maybe cropping multiple kinds of plants, etc. And again, it gives us this kind of idea of what people were doing through a really long-term scale that can help to inform future sustainable practices here on the island.
Thank you very much, Yoshi.
So, we saw back-to-back now, we saw first Dr. Anders Claudia Kraan, and then afterwards we saw Yoshi Meisumi in an interview with Nifa Ansano. So, Claudia spoke about water plantations, deforestation, the dams, the different roaming goats. But how do we do all of this? Remember I told you that in the beginning, my first connection and introduction to CCLP was here at NAM, where they gave a presentation, and our next speaker impressed me with a machine, something he had, a gadget, and he told us literally, well, I want to explain this to you, but you have to see it in the field, how we work with this. So now we're going to have a conversation with Michiel, Dr. Anders Michiel Kapers, who's an archaeologist and developer of the Interest Registries Archaeological Information System, and is specialized in archaeological data management. He's going to be online with us, and he's going to give his preliminary findings in this project of CCLP. With you, Dr. Anders Michiel Kapers.
Thank you for the introduction. This presentation will focus on the data management and digital mapping. I will first briefly mention what type of hardware and software we have used, and then go to a more detailed description of these things and items. And next, focus on the hardware, on use of the hardware, measurement systems, etc., on 2 locations, and I will focus in on 2 extremes, especially for the use of the GPS. And finally, the software that we use to further manage and process all the data. We have used different types of hardware during the fieldwork, amongst others, or mainly of all, an MLIT GPS. MLIT is a brand, GPS is the system we use. This is a 1 centimeter accurate GPS. These have become relatively affordable these days, and they used to be extremely expensive, but now we can use them also within our field. A field tablet for data recording in the field. Barcode labels and scanners, which integrate with the system and are part of the whole data management collection system. And these are also used in the lab for artifact processing and data storage and artifact storage. And finally, also digital scales and calipers that automatically center data to the appropriate fields in the database. The software that we have used and are using within this project, the CCLP, is Excel. This might sound a little simple, but this is what we use in the first step after we have made GPS measurements and we want to correct especially the elevation. I will go into more detail that in a moment. Then other software that we use is GIS software. The GIS software that we are using is, amongst others, ArcGIS Desktop and ArcGIS Online, which is used at the NAM location on Curaçao itself. We also use MapInfo to create some digital elevation models and shaded relief maps. And then finally, also as GIS software, the Interis Geo module, which is a integrated GIS module of the Interis Archaeological Information System software. And finally, as data management software, we do use the Interis Registries AIS, Archaeological Information System. This is the end system that we use for everything. All data is stored in one large database with different modules used. Interis is a modular system that have different modules which are different doorways to the same database. So we do not have to switch in the end between different software, and all the data is connected within that one database. So in earlier days, fieldwork measurements were often done with a system like this, a total station infrared theodolite system. It would comprise of a tripod, a mainframe, the system itself, the machine itself, and then another set of a reflector, the prism, and a prism pole to take measurements. It would send an infrared beam to the reflector, it would reflect it back, and with that we can measure distances, and with the angles read within the system, the machine itself, we could then determine coordinates and set out coordinates. This was already over the last few decades a modern system that we use, but it's heavy, it's difficult for transportation. You need to set up on a site, and within a site it's very accurate, but you need fixed points within sites, etc. And also one would also need a minimum of 2 people, unless one could invest in a so-called robotic total station, which would automatically follow the reflector, and then you would only need 1 person with the reflector, but those were very expensive. Now, these days, we can use the highly accurate GPS systems, making use of a base station. In this case, we use the base station of Curaçao, and with the corrections received from the base station through the cell phone network, this GPS can take centimeter accurate measurements. This is highly accurate and more than enough for our archaeological fieldwork. These machines have become so affordable that they can replace the the infrared theodolite systems. There's a caveat though. There are some challenges with a GPS system. You need open enough sky to be able to receive enough signals from satellites, and of course have reception with your cell phone network for the corrections from the base station. Worst case, you can also take measurements at some and then process it afterwards. But if you want to have live accurate measurements, then those are the features that you will need. Clear sky, or at least not too much coverage from growth and brush and trees, etc., and cell phone and network connection. I will focus on two different areas, the two different areas that have been mentioned already, and I will zoom in on two different locations that show the two extremes. One location where it works perfectly well, and one location where it's very difficult to use this. So on the island of Curaçao, you can see in the bottom half, the red dot indicates the location of the base station in Willemstad. The base station we use that for the corrections, and the work was done in the Jan Thiel area, as mentioned before in the other talks, and the Rif-Simmery area. The maximum GPS range for this particular GPS to the base station is 60+ kilometers. That should be more than enough to cover the whole island, because the maximum distance from the base station to the Jan Thiel area is a maximum of 5 kilometers. And the distance from the base station to the Rif-Simmery area is a maximum of 20 kilometers. So distance-wise, we should be able to cover the whole island with the GPS and one base station. There are other challenges though, and we had to deal with, such as rock walls, hills, valleys with bad reception, and of course growth, trees and shrub. I will first look at the data collection in the Jan Thiel area. Here are two images, two photos that show the open space at Jan Thiel. Not every section in the Jan Thiel area is as open as this. We also did some work in the Den Donkey Park, more north, where there's a lot of growth, a lot of trees, and there it was a bit more difficult, but still doable to take good measurements. But in this area where we excavated on the sand, the beach area along the lagoon at low water, it is of course very open, and it was very easy to take measurements. It was just seconds, and you have your measurements. Here is another aerial photograph, as you have seen already in one of the early presentations, and you can see all this sandy area around the bay with straight lines, which are the walls to indicate that indicate the salt pans that used to be there. And this area, we took a lot of measurements. The GPS comes with a very simple app that works on your phone, and the GPS itself has a SIM card as well, and is itself connected to the cell phone network to receive the corrections from the base station. So if the connection is proper, then the corrections will come through live, and you can see your live location highly accurate on this map. It uses a base map, and it shows all the measurements that were taken. And in the center here with the little R, I'm not sure if you see my mouse, that is the rover. The R stands for rover. The rover is the GPS we walk with, and the base station is the one that's fixed and we use for corrections. These measurements afterwards, once the measurements are taken, we download them in a CVS file, which we use in Excel to have a look at all the measurements. It comes with a lot of data, the coordinates, of course, all kinds of information about the projection and ellipsoid, etc., and also the accuracy. The accuracy you can see here: easting, RMS, northing, RMS, etc. And this is all in centimeters, and the accuracy everywhere is 1 centimeter. This is the maximum accuracy it can get So it says when it's extremely accurate, it says the 1 centimeter. It might be less than 1 centimeter, but it rounds it to 1 centimeter. These columns, this is actually the reason why we import it in Excel first. There's 2 columns here, elevation and corrected elevation. The column corrected elevation is added by ourselves because the elevation is what is stored. While it is a highly accurate system and the elevation itself is accurate, it is the wrong elevation. The X and Y is correct, but the elevation is based on the ellipsoid. These are the this is the data related to the base station. At the top, you can see the X, Y, Z as the known coordinates of the base station with the known Z level, the level in relation to MSL, mean sea level, which is 9.759 meters. However, below that is a box with latitude and longitude and the H for height, which is based on the ellipsoid. It's the ellipsoid height, which has to do with the projection, etc. I won't go into detail about that, but that is the actual height that was calculated, or that is read of the projection and the ellipsoid, which is minus 13.667 meters. But the actual level is 9.759 plus. So the difference is this number, plus 23.426. And with a very simple formula in the Excel sheet, we can then calculate the correct elevations for all the measurements. So this is the step that we do in the Excel system for GPS level corrections. Once this is done, next we can go to other software and plot all these measurements in a GIS system, for example, and create maps like these, like the shaded relief maps. I will talk about this more in a minute. So back to the Jan Thiel area measurements. These measurements were plotted in the NAM ArcGIS system. Since we took the measurements in the world projection, in this case UTM Zone North and 19 North, which is where Curaçao is located, these were then transferred into the local Curaçao grid, and all the measurements showed up on their proper locations. This is just a 2-dimensional view. Later we can use the levels as well for 3-dimensional views. In this particular case, it's all very flat, of course, because this is all around the water and it's all the salt pans. All these straight lines are measurements of the salt pan walls, or the walls related to the salt pans activities. And I'll zoom in into 2 different locations. First, this one at the top, and then next, the one at the bottom. The one at the top shows some measurements of some of the walls. We see this zigzag line. I have honestly no idea yet why it has this shape, but this is one of the walls that was there. And then right below it, the straight horizontal, almost horizontal line. We took these measurements as Claudia already indicated, because of these walls around the salt pans. They are deteriorating, and for reasons of preservation, we want to map all these walls with their current status and of course see what we can do to preserve these. The southern part, and there are some different types of measurements. First, there's this little block. This is a GPR area, a ground penetrating radar area. This is actually a little bump, a little hill, and there is lots of surface material, and based on that we decided to place a GPR section over here. Dr. Kelsey Lowe will talk about the GPR in more detail after my talk. So here we took many measurements within the square that indicates the GPR area, and with that we'll then be able to create a digital elevation model, a 3D model, on which we can superimpose the GPR results. And again, the talk after mine will go into more detail about what is GPR and what can we do with it. The other dots, measurements, the blue ones at the bottom, those are test pits and surface scatter locations. Okay, now we move to the other area, which is the Rift Marie area. here things went very different. The area in the Rift Memory area that we have looked at for several sites is the area in the blue circle. And I will focus on one of the sites that is very much overgrown, lots of vegetation, and is also next to a rock wall, which makes the use of GPS very difficult. As you can see on this picture, the GPS is between the trees. On this particular location, we were still able to get a measurement. Sometimes you will have to wait a little longer, but it was more of a challenge to get proper measurements here with the GPS. At some point, we just started work and laid out a baseline, and you can see here in the red circle, we just placed the GPS on its location and let it stand for several hours. And at some point, it would pick up enough satellite connections to create a so-called fixed point, a highly accurate 1 centimeter accurate point. The cell network, that was not really the issue here. It was purely the tree covers on one side of the site. And as you can see in the next picture, the rock wall on the other side, which of course blocks at least 50% of sky view. And there's only a very small strip of open sky between the rock wall and the vegetation, and that is not enough to have quick and accurate measurements. So by placing the GPS on 2 different locations along the edge, close to the vegetation, but away from the rock wall, we were able to get 2 fixed points. And based on 2 points, you have a line. And with the line, we can then pinpoint our local grid, which we laid out with the old-fashioned way with measurement tapes, as you can see on the picture on the right, with which we were able to then later georeference the site on its true location. So on this particular site, we couldn't do that much with the GPS. So we had to revert to very old-fashioned analog methods by using this level. On the picture, it doesn't look very level, but it is certainly level. And with that, we took measurements on along the measurement tapes that we had laid out over the site in rows and lines, and then drew them on a paper map, which is here set against the level. Here's that same picture. Here's our analog map. We drew several analog maps. This is the overview analog map of the whole site area, which is at a scale of 1 to 50. And every meter we took a level measurement in order to later reconstruct the elevations and the relief of the surface of the site. We also measured several other things, of course, the location of the units that we were excavating, and the rock wall where it touches the floor, as well as a drip line that we could see in the sand, especially in early mornings. That might influence, of course, the material in the soil as well, with the water running down from the rocks, and the edge and vegetation line and several big rocks. We had a smaller scale map of the central area where we were excavating with a large feature, hard feature in this case. And then we would even go further down in scale in a 1 to 10 scale for every square that we excavated, with detailed drawings of the different fills within the feature. So we have 3 different scales with 3 different map levels. And these were then all combined in the GIS, georeferenced on their locations, and then combined into one main map, digital map. So that would be the next step after we did our field, the technical work in the field with the equipment, the GPS and the analog material, the software that we used for processing the data that was collected, and as well the data management. And there are 2 types of software. There's the GIS software for mapping, and then we have our database system, our archaeological information system, to collect, in the end, all the data within one database with the different modules. There we can switch between and where all the data is connected to each other. This is an overview, schematic overview of the Interis software that we use. It is a modular system, and it has different data levels ranging from general project management all the way down to repository and collection management. As I said, it's a modular system. One of the modules that we also used in this project, which is, this is just a quick view of the database in the back end. These are just a handful of the tables that are part of the database and with their connections. One of the modules that we used is the import module, which is not in this schematic overview, as it is not a data level within the system itself, but it's just a functionality, a functional module. From now on, I will switch also sometimes between the software to live show you a little bit about the software. So we can first go to the import module. The import module is a system that allows to import data from a structured Excel sheet. And in this case, we use that to quickly enter all field data and the field numbers that were assigned in the field. Of course, the entire system has a main module, a base module, or project module with which you can also just manually enter all the data. And that is something that we can use also on the tablet in the field or at a desk in the lab to enter field data from forms. But in this case, we wanted to try and use the import module and had all the data structured in an Excel. And it's simply choose for each data level. We have units, squares, plana, the levels. Plana can be horizontal as a level or vertical as a profile. Features, fills, segments, and the representation of those three features on levels, on plana, etc. You simply select columns from the Excel sheet at the top that was imported, and those are listed down here, and then you simply drag. Suppose this is a column that you want to enter here. Of course, this doesn't make sense, but you simply say, okay, the data from this Excel field needs to be imported into this database field. This is what we use to quickly enter the field data. The next module, or the base module, the project management module, this is the main module, and we've been using that for a lot of things. Once the field information was imported, we can then work on artifact processing, etc. So it contains project management, field data, provenience information, the field numbers assigned in the field, and the artifact sorting, sampling, etc. The first rough sorting, first tier of sorting of material. You can even have external media, which is currently images and drawings. This will in the future be expanded with other options, but we used also for the photographs and the field drawings that will be entered in the database as well and connected to their data. And finally, the material is stored in boxes or containers, and that is all connected within the one database. So if we have a quick look at the base module, here we have an overview of all the field numbers that were assigned, and this is the lowest level that we used for import as well. This was quickly imported from the Excel sheet, and the next level would then be artifact analysis, the first tier artifact sampling. So for instance, if I look at this shows the number assigned in the field, and at the front we see a new barcode. This is the level where we print new barcode tags for every sorted material that stays together. For instance, this is number 28, and when I filter on number 28, we can see that we have a bone, animal, coral, residue, this is from the screening, a soil sample, and shell. This is all from this one number assigned in the field and is then split up here, and we print new barcode tags with this as a barcode, and this remains with the material in the bag. Other stuff that we did so far here is the images, photos, and drawings. We have started entering some of these. We are by no means done with that, but these are field photographs, which then can be viewed in here in more detail. Here is one with a photo board. of the east wall in a test unit. This can be done in a batch. You can open up a bunch of photos and it will then enter automatically, and then you only have to detail the fields of data per image. And at the bottom we have data trees with provenience information and artifact information, and each image can be connected to one or more of these. These connections will then result in, will then give you the options to go through your data. For instance, here, if I make a filter on a particular feature and say, okay, I want to see all the pictures from this feature, it will then run the query and it will show all the pictures that are related to the feature. Sometimes you see a picture multiple times, but that is in this case because I run this particular query in the artifacts, and this is connected to a number that was split up, and therefore for each of the split up records you will see that same image. But this is not only the pictures, the photographs, we also have the drawings. Here's one field drawing. Of course, when you do a demo like this, always something goes wrong. When you click a record, you will first jump, the system will jump to that record and you can see all the data part of it, but you can also double click it and then see the image itself. And in this particular case, we have a profile drawing. And this shows up because this is a profile drawing of feature 1. Okay, so these are just a few of the items that we can do with the base module. Let's go back here. Another module that we used was the geo module, the incorporated GIS module of the interior system. This is something that I already briefly showed, but once we get that information, we can combine everything in here. Here you see a data tree that shows all the database items. Some are green and some are red. Green means they have been drawn and there is a GIS object attached to it. Red means it's only a database object, but it has not been drawn yet or might never be drawn. At the top, you see all the layers, and here is external layers. I will switch back to this at the end when we talk about the GIS and the mapping. In future, we will also use the specialist module. We have not reached that level yet. This is a module that allows highly specialized specialist analytical tables, but also tables such as like carbon-14 dating tables with all the information, or isotope analysis, etc. And finally, the collections module for repository management, collection management. We will use that later as well once we reach that stage. Then other software that we use. So we had a quick look at the database software for our archaeological information system that collects all the data in the end, with which we can then do our further data analysis. We use several types of software for the digital mapping, GIS software, like I mentioned earlier, ArcGIS Desktop or ArcGIS Online. At the NAM location, we used MapInfo to create different types of map based on the measurements. Let's quickly go to MapInfo. Here is MapInfo, where we have the measurement, the results of the analog drawing that we did at the rock shelter site. At the bottom, you can see here a scanned image of that site, which is georeferenced on its location. We created a table of all the measurements, locations with the levels. Those were transferred into the point layer that you can see here, all the blue dots. And these can then be colored based on the elevation. Next, we created a digital elevation model, a shaded relief map. These maps can then also be exported and again used in Interest Geo module. We have created a topo layer with the rock wall, the main features, some rocks here loose on the surface, vegetation line, a drip line, etc. And then here is an estimated overhang line where the rock ends, and the units that we have excavated. However, the units are actually here in the Terrace software. This is where we drew everything. So these maps that we just saw in map info, such as the digital elevation model, can also be made visible in here. We can now see some of these excavated areas in superimposed over the digital elevation model. We also have done some GPR here. Again, this is something we hear more about in the next talk, but we can also put these results in this system as well as underlays. Let's turn that one off again. And I go back here to the main layers. So we see here a unit that was excavated. When I click on it, we can select, in this case, feature one. This is all part of that larger path feature where we excavated several squares. And of course, I can also add the more detailed map and zoom in on that. And then we can further digitize and vectorize the fills within the features itself. So this all connects with the other data, and this will eventually allow us to do our analysis within one database. And finally, of course, then the Inter's Geo software, which I just showed to you all. This rounds up this talk. I hope this gives some impressions of what we do technically, and thank you for your attention.
Christine, you are one of the participating researchers of the project Curaçao Cultural Landscape. What is your specialty?
I specialize in ancient biomolecules, specifically isotopic analysis and ancient DNA, and then ZOOMS, which stands for zooarchaeology by mass spectrometry. Which is essentially collagen fingerprinting. So you get your results back, and then specific markers in the data will tell you what species the bone belongs to. So for turtles, we can separate down to species of the 4 that are typically found here. So,
Okay. And by here you mean Curaçao?
Curaçao, yeah. Curaçao and all over the world as well. So it's
okay. But you also have done a research in Italy about deers.
Yes, yeah, I did intratooth serial sampling, which is where you take a segment of a tooth every 1 millimeter or so to correspond with the growth rates of that tooth.
Okay.
And then we run it through the isotopes to get oxygen and carbon, and that can tell us how deer were moving. If the altitude is big enough, you see a differentiation between their values, so you can tell that they were moving seasonally, perhaps. So if it snows at the top and there's no more food, then they have to come back down. And using that, you can then come up with ideas of how people were hunting and surviving using them, if they were following them, or if they had seasonal hunting outposts and stuff. So that's what I was doing.
Okay. Turtles are very common on the island. Deer as well, but we see them less than we see the turtles. So far, from what you guys have collected, did you gather enough information of material to be able to research these two species for your research?
Yeah, so turtles, definitely. There's a lot more turtle in the collection than we could have hoped for. I think one bag yesterday had 53 samples of turtle, and we're aiming for 200 to 300 for the zooms. And then we'll do, I think, 30 or 40 from each time period for the DNA to get an idea of abundance through time, because that's typically enough to tell proportion and to get enough information. But that number will expand if we see that there's other population structures within them, to make sure that we get an accurate representation of genetic diversity at that time.
Is it possible to identify, because you just mentioned there are 4 groups of turtles on the island, is it possible that you might identify other kinds of turtles through the time periods?
We might be able to, because they also pick up markers for 2 other kinds of turtles. I think it's like olive, 2 types of olive turtles that were also picked up in the Caribbean. There was a study done a few years back using zooms from Curaçao, was one of the islands, Grand Bay, which is a site Christina worked on actually. And they found 6 distinct markers for 6 distinct species. So we could see that those, other species of turtles were here at one point in time or another, and then maybe they were completely hunted out or not. But yeah, so if we see those, then we'll know.
What makes Curaçao special for your research?
Curaçao's great because it's a small island, so a lot of things about in terms of genetics and genetic change and variability, you can see it a lot faster on an island because everything's so small and insular that you're not getting additional species come through. So the population remains small, and then it's more likely you'll see change in the genetics over time on a shorter span. But yeah, since it's a smaller population, you're not getting an influx of other species coming from like different islands, then you see how that changes in relationship to human activity, for example, and you can see that faster scale. And then it's also important because here there's so much turtle bone and huge collections that haven't been looked at all, which is really interesting because I think there's a lot of information to be gained from the island. Yeah, and then also it's great for conservation and turtle conservation. I know there's sea turtle conservation Curaçao, who I'm going to get in contact with hopefully so I can understand what they would like to see from my research in order to make sure that the data I'm presenting isn't just for an academic audience, like it actually has a use afterwards as well. And then yeah, there's the history here, like there's been so many different cultures and so many different people and different management strategies, and then looking at how maybe in the past they were living sustainably along turtles, and then why there was such a fast decrease, if it has to do with lack of like controlled hunting or just not enough
vegetation.
Maybe yes, because the sea turtle grass, that's something we're going to be looking at as well through isotopes. We want to see if there is like 6 different species of turtle and they're all living off of this one turtle seagrass, and it was supporting their whole population. Like it was such a huge abundance then if it could support 6 different populations. But we need to look at that through time.
Okay. If we can fast forward a bit, you mentioned the Turtle Conservation Organization on the island, but besides that organization, for what other parts of the culture and preservation do you think your research might be valuable for?
That's a good question. One I might need to think about a bit more. But yeah, conservation policy making. So if we look back in time and see that, change actually started prior to climate change, prior to the warming of the waters, then that's something else you need to consider going forward, because they need to be managed differently if something prior to climate change was affecting them, because even if you remove the climate change and you're solving for that in your conservation, your policy making, if it was already in decline prior to the climate change, you also need to be able to account for that because they're still going to keep declining. So yeah, for the conservation policy making, you need to understand if there's other drivers driving their decline, because you need to account for that when you're looking at how to manage the species into the future. Because if you remove, even if you're removed for one driving factor such as climate change, it could have been hunting prior to, or it could have been destruction of sea turtle grass habitats, and then if that's not being accounted for, the populations will continue to decline over time. So yeah, looking to the past to move forward into the future, and to help to conserve them using that kind of strategy. Yeah.
Okay. Thank you very much, Christine.
Thank you. All right.
That's
Perfect.
it.
Very good.
Perfect.
So thank you, Miss Christine Conlan and Mr. Dr. Anders Michiel Kapers for their presentations. Now, after hearing about the accuracy, 1 centimeter accuracy by Michiel Kapers and literally 1 millimeter on the tooth of the turtle, the sea turtle, by Christine Conlan, we have to go here a little bit more about GPR, the subsurface mapping and using a ground-penetrating radar, a GPR, to understand site integrity at Curaçao. This will be done by Dr. Kesley Lowe, and she has a pre-recording. This pre-recording will be aired to you now, and if you have questions or remarks, you can post them on the Facebook link or on YouTube, and we will submit questions and remarks to Dr. Kesley Lowe. With you, Dr. Kesley Lowe.
Good morning, everyone. I am Dr. Kesley Lowe, and I'm going to be talking about preliminary geophysical investigations that took place in Curaçao over July 2022. I am recording this on Zoom, so this is going to need to be a pre-recorded presentation, and hopefully everything goes smoothly. It's my first attempt. So before I get too far ahead, I always like to do acknowledgement of country. I'm from Australia, and this is what we do traditionally when we are giving a talk or going on to country. We'd like to always acknowledge those traditional owners of the lands that we are meeting on today, which in this case would be in Curaçao. And we like to pay our respects to ancestors, their descendants, past, present, and emerging. And also recognize that valuable contribution that Aboriginal cultural history can give to Australia and to the rest of the world. So today's talk, I would like to do a little bit of an introduction to the sites that I'm working with. The sites that we investigated with the geophysical survey was Gentil, Reef St. Marie, and the Zorzak Gardens, which are just north of Gentil. And the method that we used primarily for this project was going to be ground penetrating radar. And I'll give a little bit about the results and conclusions as we go through, as well as the methodology. But I guess before I go through, I always like to give a little bit of an overview of who I am and what I do. And so, as I said before, I'm Kesley Lowe. I'm from the University of Queensland, and I'm an archaeologist trained in remote sensing, geophysics, and geoarchaeology, as well as geographic information systems, which Michiel will talk a lot more about later on. And what I am able to do with these different instruments is that I'm primarily interested in looking at how humans moved on the landscape and what they did to modify it. Those different human markers that we can detect often below the ground, because sometimes the archaeology is not on the surface, but it's hidden. And because of my expertise, I've gotten to work in a lot of different places in the world. So I'm from the US originally, which you can tell probably by my accent, but I've worked in the Caribbean and South America, and then over in Europe and Africa, Southeast Asia, which includes Myanmar, and then parts of Indonesia, PNG, and then Australia. The aims for the project that we have for our overall project goals was to look at those subsurface materials across the landscape and to understand about the depositional sites. So for part of what we've done alongside with NAM and the Simon Fraser University is to understand a little bit more about the cultural heritage, what we could see, and the depositional setting of each site, and perhaps the integrity to understand if sites are really well intact or they disturbed. When it's applicable, we like to look at that spatial layout, how sites are distributed across the landscape. And then we also use this information to help pinpoint future targeted excavations. This can often be done in a way to minimize the impacts that we do in archaeology. So for this project, I was only able to come to Curaçao for probably about 2.5 weeks because of time constraints and other commitments to projects and COVID and everything else that we have all had to deal with. So the projects I primarily worked on were in these areas. So this is up here is we've got, the Reef Sainte Marie. So we did 2 different surveys in this location. And then here's the Gentil. So these are our 2 main areas of focus for the 2022 investigations. And I have the grids laid out in red. This is zoomed out, so you can't see them in detail, but we did a few grids in the Zorzak Gardens and then also the shell mounds in Gentil. And then we did a rock shelter up here, which is called Geophysical Survey Area 4. And then we did a little bit of a small transect. And we would love to do more, but there are some limitations, which I will discuss in the next few slides. So now I'm just going to play a little video that I created in as part of the university to talk a little bit about the method. And I think this video does a really good job of summarizing how GPR works and why it's being used. So bear with me.
Ground-penetrating radar, or GPR, is a great way to see the subsurface without digging it up. The technology works by transmitting electromagnetic energy in the form of radar waves or pulses into the ground. When the waves encounter a different material in the soil, such as air voids, stone, or material with different moisture content, a reflection occurs, sending part of the wave back to the surface, where it is received and recorded by the instrument. The remainder of the radar wave continues downward until parts of it too are reflected back to the surface by deeper objects, or it dissipates from being absorbed by subsurface materials. The time which transpires between transmission and reception of the radar wave from the antenna to the ground is measured in nanoseconds, and mathematical calculations can approximate the depth at which a reflection occurred. In general, the greater the depth of investigation, the lower the antenna frequency. Low frequencies have a longer wavelength, many meters, providing less resolution, but enabling transmission of the wave much deeper, up to 8 to 10 meters. Most low-frequency antennas are large and heavy and often towed behind a vehicle. However, for shallow depth of investigation, the higher the antenna frequency. High frequencies have a shorter wavelength, providing a high-resolution view of the subsurface, though the wave does not transmit to a great depth, approximately 0.5 to 3 meters. This survey here is carried out with a 400 megahertz antenna. GPR data is collected in a series of reflection profiles, 2-dimensional cross-sections of transect data, line of collected data. Transects are generally collected every 0.5 meters, as shown here. Advanced software programs have provided a way to merge reflection profiles at defined depths to create amplitude or time depth slices of the data, providing a map or image of buried deposits. Such data can also be constructed into 3 dimensions, making it especially suitable for mapping soil compaction and void spaces, as well as buried stratigraphic changes.
So that's your surface layer right there, but you can see that we've got some different changes based on our texture that the GPR wave is picking up, and also a layer here. And then the bottom layer, which we start to get, which we do know there's 3 layers here. So it's picking up all 3. We do, and also have us change at the very end here of something of a higher contrast to the sandy material, which is picking up and causing a nice hyperbola peak at the very end.
All right, so on to the next slide, just so that gives you an idea of how GPR works. I think the video summarizes very well what we're doing in terms of the type of geophysical instrument we're using for this project. And I just put this slide in as a reminder of how the radar works. As you can see in the video, I was dragging the instrument across the surface, and what it does is it's sending that wave down below, and it's detecting anything that's different from the underlying material that we're working with. In that case, it was sand. It's a small little constructed site that we have at the university, and we were mapping some of the historical and indigenous features on that landscape. And then this slide here just shows you that two-way travel time that we have. And then you can see in the image, this is your reflection profile. And when you take all of those different data together, you can stitch them to create a two-dimensional map and do these nice slices, time slices, we call them, as we work our way into the deepest part of the deposits that we can reach with that instrument. As I said, with this project, we were able to do quite a few different survey areas. However, as you can see with that video, I have to drag that instrument across the ground. So ideally, working in a golf course is the most desirable place to go. But for our project, we were working in the dead of summer, and you can see here that the vegetation was one of the biggest issues for accessing size, accessibility, and being able to take the instrument to places. We had to do some clearing, in fact, to even create a GPR transect over certain areas. So that is a major limitation when it comes to using instruments, because this instrument works by having clear contact on that ground. Surface area and visibility has to be pretty good and pretty clear for the most part. You can do a line, but you wouldn't be able to do a grid in some of the locations. And this is something we did for this project. Instead of a line of data, we would call a transect of data. And as you can see there, there's a little image of a person. That just goes to show how thick this area really was. I have to say, I've worked in a lot of places. This is probably one of the thickest places besides the southeastern part of the United States, such as Mississippi and Alabama. All right, so now I'm going to move on to the results. I know I have a bit of time to go over this, and this is all preliminary data. So keep that in mind when we're talking about some of the work that's being done here. And we're going to start with the first area of investigation, which was all in Yantiel. So this area we defined is area 2D. This is an area map showing you the location, which is located there in red. And then this is what it looks like. I took some photographs before and after I was surveying just to get an idea of that landscape. Right here is one of the edges of the grid, and we do have some topographic changes, which will affect some of the GPR readings, but those can all be topographically corrected. Just because when you're on a slant, your GPR antenna is also on a slant. So we'll be mapping things in a different locality. What I've done here is I've created some overlay maps to give you an idea of the results that we're looking at. And this is basically you submerge and overlay several layers into one. So in this first image, I've overlaid the data from 0 to 30 centimeters because I didn't see a lot of changes, major changes. And I did another overlay with 60 to 90 centimeters. And as you can see with these images, we've got some high reflections down here where we first started. And then as we moved our way up on top of the shell mound, we've got a couple of high reflections here. And this is the reflection profile showing you those changes. So we've got a really strong contrast between the surface and the underlying material surrounding it. And this is predominantly shell. We can see those deposits here in depth when we're looking at it in profile. And as we get deeper, we start to probably hit that saltwater band, which can cause some attenuation, makes the signal gets really noisy, and it starts to cause a lot of bouncing back. And we start to see some of that change here. But this really hard area, I'm defining it as a compact shell deposit or something that has an energy where it's harder to get that radar signal down. And we know from walking around, some of these areas were more compacted than others. Could be from other different disturbances or erosional processes or anything that has a stronger, harder material, such as rock or types of things that, don't allow that radar signal to go down very deep. And you can see that it extends quite to about, a meter below surface, and then we start to lose contact with that. That was the results there. When we're looking at the shell deposits itself, we can see that, for the most part, you're going down, we've got some good contrast to about 124 centimeters below surface. And then we start to really lose our data at that point. And that might actually be the ground surface in some of these areas. And then we start to get into that clay area where the salt water has infiltrated and no longer getting a good signal with depth. This is some profiles where I collected magnetic susceptibility data, but it gives you an idea of how dense some of that shell deposit is in some locations and how in other areas it starts to change, and we've got that nice hard compacted layer. This area is a little bit off of the area we were investigating, but it shows that the shell deposits itself were probably about 20 to 30 centimeters. So if we go back to look at these, most of those are concentrated up in here where we can't really pick out those defined contrasts unless I've shortened that data and enlarge it and look at it in more detail. But this area is a little bit further down, and it looks and appears that a lot of that shell is extending to about this depth here because it's more of a mound where the other ones are thinly scattered on these topographically higher areas in this. And then we've got the area where we have less cultural material that's sitting on top of that. At Zorzak, we did 2 grids, but the data for the GSA3 wasn't finalized because we had some issues with our survey wheel. And this was the project that we did with the volunteers on a Sunday afternoon or Sunday morning. So it was really nice to have community members come and assist us while doing this work. And we've got one of those community members here. And then we have 2 of the students from Simon Fraser. And in this area, because I can't have a more zoomed in version, there are the gardens here that are just probably known by most of the locals to be an area that was excavated in the past, but also has a lot of interesting material inside and outside the garden walls. And what we are doing is doing some GPR surveys outside the walls because this was an area that didn't have a lot of trees or vegetation. I should add that trees are another limitation as their tree roots create, a lot of different signals and noise in the data that often are mistaken for archaeological features. So I try to avoid trees as much as possible, or I make a note of where they are. And here we are doing some GPR survey just outside that wall area. And this gives you an idea of what we're looking at. So to put into some context here, the actual wall itself is located right here. So in the previous image, I was taking it from this location. There's the bridge that comes right over in this area. And then we start to work our way south in this area, the general vicinity. And these are areas where we weren't able to survey because of vegetation. And again, you've got some high reflections near the edge of the bridge, which is what you'd expect to see. It's probably related to the construction, but we've also got some high reflections here. And as we go down with depth, I should move my little screen because this is actually the 60 to 90 centimeter depth as we go down here. And we've got a lot of different contrasts that are showing up. And in fact, we start to pick parts of it up in this slice, but then as we get deeper, we can see a lot more of them poking out. This too might be related to the construction of the wall. And this one is probably related to the tree that you can see. So a large tree complex area here. And then we've got other stuff. And we don't necessarily have to always test things that have the high reflections. So again, those high reflections are in the yellow and the red. We can also look at things that are in the blue, which might be weaker reflections and might be different changes that are not associated with the same material, but maybe wooden materials. And so we did put in a test pit. I don't know the exact location, but I think it was somewhere over here to test one of these anomalies or this anomaly. And it was really compact. I don't think we got down more than 30 centimeters given on time, but we can see that it's a nice gravelly layer and you can see that on the surface. So whether that's related to, again, the construction of the gardens or it was used as a dumping area, that's something that needs to be further investigated. But certainly it might be worth testing some of these areas right next to the wall itself to see if those are old rubbish dumps or have an additional material in there, such as shell. And I do have some reflection profiles, but given on time, I think I wasn't going to be able to put them in here. I'm also trying to track my time here, just next to my, this presentation. So the next site I'd like to talk about is Reef St. Marie, which is the rock shelter located in this area called Site 11 or Area 11. We referred to, and there's two different names. And this gives you an idea of this area. And I was really excited about doing this site because, one, it's a rock shelter, and GPR is really good at looking at depth of bedrock on sites like this, but also areas where there might be roof fall, because oftentimes these are things you're going to be encountering. It also gives us a really nice profile of what it looks like stratigraphically. And there was, of course, no issues with vegetation, which at this point was a big concern of mine for this survey this year season. Again, giving you some more perspective. This is nice also because we came there after a rain. You can see these really nice dark features on the surface, which are combustion features, which is pretty cool. Often not so easy to see when they're dry, but with the water, they create a nice color scheme that gave us an idea of looking at the other archaeological features that might be, not so obvious to you on different daylights. And again, context of where the site is located. Now, these are some profiles that were collected from the GPR. Again, we're looking at those different depth slices. And note that this right along here is the shelter wall. As we got closer and closer to the shelter, we had less area to go because the shelter is tipping over. And this is looking at the outside. And again, we've got a lot of high reflection sitting there. And this is kind of just below that drip line. So again, when material is falling down, it's falling just right on the edge of the site, which you'd expect to see. And these are what we're seeing in these high reflections. So we've also got some areas where the bedrock is being a little bit more exposed, and that's what we're picking up. And again, when we look at the 30 to 60, we start to get into different areas, and we're starting also by 60 to 90, picking up the underlying bedrock underneath the shelter itself. So these shelters are formed because they are different type of, in this case, coral formations, and over time, erosion from other parent material will come through and create like these little sand traps that allow for sediment to accumulate. And that makes it a desirable place for people to go because they're nice and cool and it's soft, and they can stay and camp there for a few days or use it for other purposes, if not camping, maybe for ceremonial. And so this is why you expect to see cultural material in places like this, because the sediments are, quite nice to stay on and, as I said, camp or spend a few days through shelter. And these are the reflection profiles for the different slides. So I guess when I talk about these reflection profiles, each one of these files, we've got a line of data that we collected, and that's what we're starting to see. So our first line of data was collected this way, and then as we moved our way through the shelter, they become shorter. So this is what you can see is the first lines. We've got, long transects there, and as we got closer to the shelter, our lines become smaller and smaller. And probably one thing that you really pick up is that it's really quiet on us outside because we haven't really hit those bedrock deposits. We're starting to pick up some, changes here, and we've got a little bit of changes that are occurring there that are probably related to the edge of the bedrock, but then bits of the roof fall. And then as we make our way closer to the shelter wall, we get really, really strong planar reflections that are showing up here. And that's because that energy is just hitting the bedrock itself and it's bouncing back. And by the middle of the grid, that's all we start to really see. And there's a little bit of profile, maybe up to 30 centimeters we have of material. In some cases, it looks like we might get down to 70, give or take. And this is just, again, an algorithm. It's not exact depth, but it gives us an estimate of getting an understanding of what we're looking at. And we can use that to help us target those excavations, or at least know what we're doing. And we know that we use the GPR data to help guide us so we can make sure we get those deeper deposits because they are really good sediment traps for chronology and time and preservation. So that was the idea of what we were doing and using this data to support that. But we can also see as we move closer into the shelter, we probably wouldn't want to put a lot of units in there because we would hit the bedrock right away. And this is just a quick, profile. I was collecting some data. I know that these are taken by myself. There are much better photos out there, but it just shows you the complexity of the stratigraphic profile. We're probably down maybe 10 centimeters or so. It's also at an angle, so it's a little bit hard, but you can see all the different ash layers and the darker layers full of organics. And I'd have to go back and re-look at those profiles a little bit more to see the GPR profiles, to see if we can see those different layers. But I imagine we can't because they're so fine and compact that the GPR is just going through all of it. But once we hit the bedrock, because that's a different energy, that's creating a much different reflection. And that's what we're actually seeing rather than all of these different sediment layers. But we will do some geoarchaeological analyses and we'll compare that to the GPR. And I'm hoping that by next year, they'll have a deeper profile that we can really examine and compare the two data sets with. Now, the last site that I worked on is the slave quarters. I hope I'm not going to over time. I'm going to make this go a little bit quicker, but we can only collect a transect of data here. It would be awesome to be able to go out and map this entire landscape, but we just can't do that based on the environmental conditions of the vegetation. This is the GPR transect we collected. It was very rough. It was very hard. But we were able to get, one line or 2 lines of data. Here's just a map showing the location. And then this is, I'll move myself over as the profile of the data that we're getting. We didn't get too deep, about 141 centimeters, but you can see we've got some topographic changes. These are probably tree roots in some cases, but we also have a little bit of quietness, and then we start to pick up a different lens. And here's the profile when we come back. So we do have a little bit of change here. It's hard, though, to pick up, any definable structures or immediate changes because we only have one line of data, essentially. And so to make sense of what the landscape looks like, we would need to collect more, but we can get an idea of depth of material. We can see a change, a little bit around here on the 50 to 60 mark, and then we start to get more quiet data in this area. But we do have a little few changes here, which we call these hyperbolas, which are probably related to the tree roots because there were a lot of trees in the area, but it could have something to do with structural material as well. Anyways, so I'm just going to now wrap this up because I think I'm a little bit over time, and I apologize for that because I'm pre-recording this. But I wanted to say so far what we were able to achieve is that some sites provide a lot of interesting and useful data that we can use for future investigations, and other sites such as the slave quarters makes it really hard to discern what's happening because the vegetation is obscuring our idea of what that landscape looks like. I'm sure there's a lot of pits and other things that might be related, and perhaps using another instrument, if the vegetation wasn't there, would give us that more of that 2D look that we're hoping to get. I'm hoping that the next time we come out that we have areas where it might be a little bit more cleared. You can see that geophysics is heavily dependent on whether or not you can access the site in terms of getting to it and walking around. As a landscape archaeologist, that's really imperative to be able to see sort of those features. At sites like Area 11, we're able to also take the information from the GPR profiles and relay that back to the excavations. And that might be the same thing that we do at SORSAC too. When we get that data, we can start to look at the different depositional history and make more concrete analyses and recommendations. So with geophysics, it's not always necessarily me finding stuff and saying, oh, this is exactly what it is. It's actually talking with the archaeologists. We work together and to refine our understanding as it's a learning process, and each site and each landscape I work at is a little bit different. So this is my first time in Curaçao, and so it was a learning experience, and I'm sure there will be a lot more information to come. And I would just like to thank, our partners in all of this project, the team I work with, the students, NOM, for allowing us to come and work with them and be part of this project, and then our different funding sources. Anyways, I will wrap it up here. Thank you.
Thank you very much, Dr. Kesley Lowe. Remember, if you have any questions or remarks, you can post them in the comment section either on Facebook or you can submit it on YouTube. So this morning we're going over information, we're getting information about the cultural landscape of Curaçao in the CLP project. I'm learning a lot about our history, our past, and moving on to the future. So after seeing, because this I laugh now and now I understand why they mention and call it an X-ray, but after understanding what GPR is, we're going over to the human and animal interactions in Curaçao's past, and this by Dr. Christina Govias. Dr. Christina Govias is an associate professor of archaeology at the Simon Fraser University in Canada. She's a specialist in analysis of archaeological animal remains and Caribbean archaeology. With you, Dr. Christina Govias.
Bom dia, good morning, and welcome, and thank you for the opportunity to be here to speak to you today. I'm really pleased to be back on the island of Curaçao to join this symposium and talk to you a little bit about my area of research, archaeozoology. As Elton mentioned in his very kind introduction, my name is Dr. Christina Jovas. I'm an archaeologist with Simon Fraser University in Canada, and I'm one of the co-directors of CCLP. So I'd like to begin by providing a bit of an orientation by first reviewing some of the CCLP's research objectives. To help understand those goals that we have, it's useful to know what the term cultural landscape means. A cultural landscape refers to a place that exhibits through its natural and cultural history a long and intimate relationship between people and the local environment. And the CCLP is looking to document and understand that relationship by developing records for human-caused habitat and biodiversity change from initial settlement of the island some 5,000 years ago, all the way through up until the present. We are looking to apply the knowledge that we've gained to modern environmental conservation efforts, and we're doing that through survey to locate archaeological sites around the island. We're mapping those sites and historic structures to assess land use and change, and we're conducting excavation and coring of inland bays to collect ancient plant, animal, and soil samples. So I'm the project's archaeozoologist, and within the goals that you see listed here, my focus is on those animal remains and how they can help us address those first two research goals related to biodiversity and conservation applications. So what exactly is archaeozoology? It's also known by the term zooarchaeology, and you might hear me move back and forth between those two terms throughout this talk. Archaeozoology is the study of animal bones and shells from archaeological sites. It can tell us a lot. It can tell us about human resource use and diet, what people were eating in the past, how they exploited animals. It can tell us about things like the process of domestication, how and why that came about. And it can tell us about some of the more intangible aspects of the past, including things like the role of animals in ritual and symbolic behavior and activities by people. The CCLP has some very specific goals related to archaeozoology and understanding human-environment interactions in the past. We're interested in looking at fisheries management through time, its sustainable use, and possible overfishing in the past of fish and shellfish. We're also interested in understanding the impact of the introduction of non-native species like the goats that Claudia mentioned in her earlier talk. We're also interested in investigating extinctions, looking to document those and how they might relate to human activities. And then finally, as we saw in the talk by Christine Conlin, we're looking to reconstruct sea turtle population dynamics over time. And I'll briefly go into that a little more towards the end of this presentation. We're targeting several species of interest to answer these questions that we have, and almost all of the animals that you see listed here on the screen are known as flagship species. Those are ones that are identified by the Dutch Caribbean Nature Alliance as conservation priorities. In the words of the DCNA, flagship species are ones that have a value that's intrinsically linked to the island. In addition to endangered and endemic species, flagship species can include ones that are iconic or charismatic in some way, ones that are emblematic or associated with the island and its culture. And flagship species also include those that have a particular economic or recreational value. So our aim as a project is to use archaeology to provide long-term records for the population health of these animals and the nature of their interactions with humans over time that can inform conservation efforts in the present. We're interested in parrotfish and crown conch, for example, to evaluate possible overfishing of these animals. Both these animals were widely used in the Caribbean by indigenous peoples, and the populations of both have experienced declines in the present. Other species of interest include the Curaçao deer, which was introduced by the Kakatiyo Indians, as Claudia mentioned in her earlier talk. But its timing of arrival and its origins are still uncertain. So this is one thing that we want to investigate further. Along with sea turtle population dynamics, you can see that there are 3 species listed on the screen, but as Christine discussed earlier, there are actually 6 species of interest here that we're looking to understand better how they were exploited by humans and what their populations have been doing over time. And we're going to reconstruct that using ancient DNA from the sea turtle bones as well as stable isotope analysis. So to address these questions, we rely on multiple lines of evidence, beginning with the animal remains themselves. So we collect shell and bones from excavations of archaeological sites. We identify the species that they came from, count the remains, and reconstruct the number of individuals that are represented. We can take measurements on certain skeletal elements and use these to reconstruct the size of the animal when it was alive, and this allows us to look at phenomena like overfishing or overharvesting of shellfish, which often yields a decline in the average size of the average body size of the animal population. We can extract DNA from bones where this is preserved to look at the genetic profile of the species and determine how ancient populations might relate to modern day ones. We can also detect whether those animals have undergone any population bottlenecks due to things like climate change or other environmental factors, or perhaps human hunting pressure. We can combine these data with analyses of bone chemistry based on isotopes that are contributed through the animal's diet to understand what it's eating and its position in the food web. And then this in turn can tell us about changing ecological relationships among animal populations. Lastly, but not least, the associations between shell, bone, and other materials in an archaeological site, meaning how they all relate to each other in space, allow archaeologists to determine how those animals were used. So they really provide, those associations allow us to reconstruct the cultural context. The shell and bone that the CCLP is using to answer these questions come from excavation at 2 locations that you've already heard my colleagues talk about in earlier presentations, Salina Sainte-Marie and Salina Yantiel. This past summer, we excavated a number of locations around these 2 landscapes, and an example of one of those excavation units can actually be seen in the top of the screen in the center image. And that actually also comes from, that picture that you're looking at comes from Test Pit 9 at Yantiel, which was mentioned earlier. And I understand that we've had a question from one of our viewers who's watching us, joining us live today, about the age of that shellman that's represented in the test pit. We don't actually know the age of this yet. We have yet to apply radiocarbon dating, but it's one of the things that we'll be pursuing. So we can date the actual shell and get an age for that deposit based on it. We suspect, because of the archaeological context and the nature of the archaeology here, that it's probably archaic in age, which would make it somewhere between about 1,600 and 5,000 years old. So stay tuned and watch this space. So a shell midden is one. The shell midden that you see there is just one of several that we were targeting across these landscapes. A shell midden is essentially a technical term that archaeologists use to refer to a dense pile of shell that's accumulated over time due to humans just discarding the remains of their shellfish meals. We also collected sediment cores from each of the bays to reconstruct vegetation and forest cover around the lagoons based on the fossil pollen contained in those cores. So the excavations tell us about what people are doing at specific points, specific places on the landscape, while the cores tell us what the environment looked like for the lagoons as a whole in the area around the lagoons. So we can combine these multiple snapshots and we can take these snapshots through time and get a sense of how the landscape and the bays changed over time and what role human activities may have played in this. The animal remains that we excavate are typically recovered when we pass the excavated sediments through a mesh to capture even the smallest shell and bones. So this is really critical for archaeologists because if we don't use this procedure, we can miss some of the more important aspects of resource use and diet that might be captured with those small remains. So for example, the use of nets to capture small fish is information that we're interested in but would be lost if we didn't use these screens because those small bones are too small to be visible with the naked eye and picked out by hand. So we let the screens do that job for us. After that, the bones and the shell are cleaned, they're sorted, and then they move into the lab for analysis where they're identified, counted, and additional analyses are performed. And of course, as I mentioned, my role in the CCLP project is to conduct those analyses. And that's exactly what I've been doing in the last few months since we wrapped up excavation over the summer. So far, I've been able to analyze or conduct an initial analysis of shell and bone recovered from one of the excavation units, Test Pit 486, at the rock shelter site at Salina Sainte Marie. This excavation was conducted about 1 kilometer upslope. The site itself has not been dated yet, but from the nature of the archaeology, we believe that it's also archaic in age, so again, somewhere between about 1,600 and 5,000 years old. The archaeological deposits are not too deep. You can see them in Test Pit 486 in the image that's on the screen. They're about 20 centimeters deep, and in the course of excavation, we subdivide those archaeological deposits into 5 centimeter increments known as plana or levels. And in this case, we had 4 within the test pit that you're looking at. The archaeological deposits are the ones that are represented by the dark sediment in that picture, and you can see they're overlying a lighter colored soil that has no archaeological remains in them. So in this particular instance, we went from the top of the sequence all the way down to the bottom of the archaeological deposits and entered into sterile soil that would have been the original living surface that people occupied. So as we go further down through the excavation, we're essentially going back farther in time. So far, about 2,100 specimens have been identified, and about half of these are to species or genus level, which gives us high-resolution environmental data. And more of those high-resolution identifications will be possible with additional work. In the image that we're looking at here, this represents the total results for Test Pit 486. And the graph depicts the numbers of shells and bones identified for each animal class, grouped according to planum, or those depth levels. So for example, the dark blue bar represents the counts for fish specimens for planum 1, 2, 3, and 4. Among vertebrate animals, most bones are in fact from fish. There are fewer bones from mammals and birds, and there's about a moderate amount from Lagadici, or from lizards. Among invertebrates, so animals which are represented by external shell rather than bone, marine and terrestrial snails and bivalves like oysters are the most common. It's really important to emphasize that all the fish and all the shellfish that we see at these sites are here because people transported them from the bay up to this site for cooking and for consumption. They're not there by accident. The number of bones and the number of bones and shells actually show evidence of burning as well, so indicating cooking. There are also a fairly large number of land snails in these deposits, especially in that last planum, planum 4, which overall had very few archaeological remains, but an abundance of land snails. And the reason why is because we're getting a tapering off of those archaeological deposits as we transition into the non-archaeological or sterile sediments. So because of time limitations, I really can't talk about all of the animals that we've identified so far. So I'd like to focus on just a few of the highlights. Among the fish, we have two kinds of gutu, or parrotfish. They're represented by the genuses or genera of Scarus and Spherosoma. And this is really good news for our project because these are one of our target species that we're interested in looking at for overfishing, or for signs of overfishing. And they're also one of the most common fish in Caribbean archaeological assemblages. So at archaeological sites on other islands, researchers have shown that the average body size of these fish actually declines over time due to overfishing, and we'll be able to test that here on Curaçao. We also have another reef fish, Kleinvischi, or the surgeon fish, is also present in the assemblage. And this isn't surprising. These two fish often co-occur, and they're often found frequently together in archaeological deposits. And other fish species are yet to be identified. We're hoping to get those results soon. As I noted before, there are tremendous numbers of land snails among the animal remains. The two most common are the larger Coquelicci di Carne and Coquelicci di Cabrito. And as anyone who lives on Curaçao knows, if you go out into the bush, you will see these two snails everywhere. The other large species is one known as Drymaeus elongatus. This is a snail that today is found only in areas of natural, undisturbed vegetation. So its presence in these archaeological deposits is a sign that forests around the site were probably relatively intact at the time of site occupation. There are also three very diminutive land snail species that we've recorded. These are all less than 1 centimeter long, so they're quite small. In the photo in the top right, you can actually see one of these species, Cistylops raveni. It's next to the tips of my tweezers, and this was a happy surprise when I encountered this in analysis. Given their small size, these latter species were probably not part of human diet. And in fact, despite what some archaeologists have previously stated, we're beginning to question whether the land snails in archaeological sites were actually consumed. And that's because their archaeological occurrence is easily explained by those snails being present in the surrounding habitat and then being incorporated into archaeological deposits through natural processes. So whether or not these snails were eaten is something that we're actually looking to systematically test as part of our research. Continuing on with shell, but moving to the marine environment, mangrove oysters and the West West Indian murex are the most common among all the invertebrates that we've identified in the assemblage so far. The mangrove oyster grows on prop roots of mangroves, and its presence in the assemblage suggests that the bay was fringed with mangrove habitat as parts of it are today. This lines up very nicely with the common presence of the murex, which lives on mudflats in protected bays and lagoons, often near oyster flats and mangrove environments. So we would expect to see these two things together in the natural environment, and here they are again together in the archaeological assemblage, and people are consuming them together. Also present is the carco indienne, or crown conch. Many of the specimens at the site are very large, and you can get a sense of that from the bottom image. The three shells on the left-hand side are melangina, or crown conch. This is a species that's very rare on Curaçao today and generally much smaller than its ancient counterpart, due likely to overharvesting. It's also another one of our target species of interest, and it will allow us to look at this question of overfishing in more detail. Lastly, I wanted to briefly discuss our sea turtle research, which my PhD student, Christine Conlon, who's leading, has discussed a little bit earlier. We've recovered turtle bone from our excavations this past summer and have combine this wider sampling from multiple archaeological sites across Curaçao and Bonaire. The bones are currently undergoing proteomics, or zooms analysis. This is a method which allows species identification based on a distinctive signature, if you will, of the collagen that's contained or preserved in the bone. After that preliminary step, the bone will undergo further testing to identify the turtle's diet and genetic profile. It'll be a little longer before we get those results, but we're very excited about the data that this research can provide. One possible application is to look at sex ratios through time. The sex of a turtle is determined by the temperature at which the egg incubates, as many of you may already know. So females result from eggs that incubate at higher or warmer temperatures. The increasing feminization of sea turtle populations is a concern in this era of global warming. Sex ratios from ancient turtles may shed light on how these charismatic species coped with climate change in the past. So we're excited about that potential application. While there's still much work to do, the early results suggest that people at this archaic site by the Sainte-Marie Bay were relying fairly heavily on marine resources. We can see this in the abundance of fish and shellfish remains that we have at the site. The ecological profiles of the most common mollusk species suggest a mangrove environment around the lagoon and an undisturbed or minimally disturbed forest around the site. Of the species of interest to the CCLP project, only the Curaçao deer has not yet been identified. And this really isn't unexpected because it's thought that the timing of introduction actually occurs much later than when this site would have been occupied. Nevertheless, most of the species of interest are present, which is promising for our project and for our collaborators in terms of research potential and future conservation applications. So we're excited to see what comes next, and we hope that you will join us again in the future years to share those discoveries. So to conclude, I would like to thank you for your kind attention, and also thanks to the many, many people, organizations, landowners, Curaçao government, who helped support and make this project possible. With immense gratitude, Dunky.
So, thank you, Dr. Christina Govia, for your presentation. And now we're going over to actually Q&A. There have been some questions posed. So now Dr. Anders Claudia Kraan will take the seat and she will be answering some questions.
Yeah, we received some questions from our onlookers, and one of them is by Gitje G3. He says, it's nice to get unbiased data about the past of our island. I, however, wonder about how much will be found underground here, because our ground is pretty solid. And that's correct. That's why a lot of archaeological material is right on the surface and will not go very deep into the soil. It depends on where you are, but usually the thickness of the find layer is not that thick. So, but there is still a lot, I can assure you. Another question of the same person is that it might be slightly off topic from the current presentation subject. Is there more documentation from the colonizers, and for what reasons aren't those included in the history books? Well, we're also working on or addressing more information on the colonization period within the CCLP. So hopefully those results will later on be incorporated in our history books for schools. Another question, I think, to what extent does this project focus on landscape dynamics of the post-colonial modern period? Well, we will address, actually, as I said in the beginning earlier, is that we will do a deep time research, so that means that we'll start with the oldest habitation of the island, but we'll also include information, of course, from later on, and we'll go until about early 20th century. Yeah, well, that's the whole, yeah, so we'll include the post-colonial modern period as well. I think those were the questions for now.
For now, there are more questions.
I hear there are more questions coming, so stay tuned.
Don't worry, but I have a question for you.
Okay.
How, even though people won't be able to see me, how was your experience for doing this research while you're actually one of the archaeologists of the NAM, and in such period of time? How was this experience for you?
Oh, it was very interesting because I've never been involved in such a large project with so many specialists involved, and it's a good learning experience in different aspects for myself, and I think for our organization as well. And one of the things of this project, you know, we're working here with 2 archaeologists, and the problem is that 2 archaeologists is not that many. So that means that really larger project and more in-depth research and analysis is not possible for us to do that. So this is why I'm so happy that we have this long-term cooperation with Christina and the other archaeologists and other co-directors, and we're hoping to do a lot more and really make a step forward in addressing the past of Curaçao. And the last question from Rex Stewart: what mechanisms are in place to preserve archaeological resources on the island so that they can continue to be researched in the future? That's a very good question. At this moment, there isn't really active management of archaeological features or structures or resources on the island. Some of the archaeological sites are in national parks, so they are sort of more or less protected. There are also some officially legally protected sites, but the problem is that we don't have a management in place, but that is actually something that I'm going to look into, because I'm preparing a project where I would like to involve the public long-term to address this and monitor archaeological sites. It's double. It's creating awareness with the public for the importance of archaeological sites and the context of archaeological finds, so that people won't remove shells in places where they shouldn't, for instance, or other archaeological finds. And it would also help us, because we are with only 2 archaeologists, to help us to have more eyes and ears on the island and know what's going on. And I'm really looking forward to work on this project, and I hope we'll succeed in getting that in place.
And then, no, really, have another one. Will there be an underwater investigation as well?
Well, at this moment, we don't have the expertise, and although we do have in our system, we use ArcGIS for as our heritage list, and that also includes maritime archaeological sites. At this point, we don't have any maritime archaeological research planned. However, we are the organization on Curaçao that have to advise the government if any development is taking place in the sea or in the water. And if there will be a moment that we have to advise that there has to be maritime archaeological research, we can always ask our network and hire other people to help us. So it's something that has our attention, but with only 2 people and a lot of work to do, we're just doing. It's kind of
Awesome. Thank you very much, Dr. Anders, Claudia, Kren.
You're welcome. Thank you for all your questions.
So, as you can see, it was a very interesting and engaging morning. Had a lot of information, we learned a lot, and I'm very proud. I didn't mention this in the beginning, but this is my closing statement. I'm very proud to be the president of the board of the NAM, and it was an honor for me to be here as the moderator. Before we close off, of course, we have to thank everybody. What we want to acknowledge also, as you notice, there were certain difficulties with social media, Facebook, YouTube. No worries. Thank you for your attention. What we will do is we will ensure that the whole presentation will be posted on Facebook, on Instagram, on YouTube, so you can re-look at it, what I'm going to be rebroadcasted, so you can follow up. If you have any questions, remarks, our doors are always open. You can send email, you can post questions, and surely we will answer that to you. So thank you for your patience. Thank you for being here with us, and we will acknowledge it. Again, for me, an honor and pleasure being here. Curaçao Cultural Landscape Project is not an end of it. It's a new beginning. It's a new era. As our director Dimitri mentioned, we're moving from one stage to the other, looking to our past in order to move over to our future. It was also highlighted and by Dr. Claudia Kraan, and by Dr. Michiel Kapers, and by Dr. Kesley Low, and by Dr. Christina Govias, looking at our past to the future. I want to thank to all our partners and collaborations with National Archaeological Anthropological Memory Management Foundation, Social Sciences and Humanities Research Council, Simon Fraser University, National Geographic, QLC Incorporated In-Terrace Registries, Max Planck Institute, University of Queensland, our participating archaeologists, Dr. Claudia Kraan, Dr. Christina Govias, Dr. Michiel Kapers, Dr. Kesley Low, the ones who couldn't be here. However, they participated, Yoshi Misumi, Christine Conlon, Amy Victorina, and of course a special thanks to all the volunteers, students of Simon Fraser University, the local volunteers, Nifa Ansana Creative Inspirations, Base Creatives, Kura Livestream, Rafael Maduro, our intern at the NAM. It was a pleasure and honor. And if you have more questions, don't forget to come to us, send us emails, and follow us, because as of 2023, as mentioned already, it's a new era. More research, more opportunities in order to move forward Curaçao Cultural Landscape Project. Thank you very much, and have a nice day further.